In this video, you'll be learning how to find the equation of a sinusoidal function and how to use that equation to find intervals at given x values. So for number 1, it tells you that you have a low point of negative 200 when x equals 22.5 and a high point of negative 150 when x equals 24.8. You use this graph to find your equation. So to find the first term in your equation, you take the difference between your high and your low and divide it by 2, which gives you 25. In this problem, it is negative because the cosine starts down and ends down. If it was a positive cosine, it would start up and end up. Next, you find your b value. This is found by using the equation PB equals 2 pi. You find your b value by finding the distance of one full wavelength. This equation only gives you a half a wavelength, so you have to subtract the midpoint from the starting and multiply it by 2 to get 4.6. Then you need a starting point, which is 22.5. This is written by x minus 22.5. Lastly, you need the midpoint between your high and the low on your graph. You do this by adding your first term to your high point to give you negative 175. Once you have your equation, you can go on and find your intervals. B asks you to find the first interval where the function is less than or equal to negative 180 after the x value is 0. To do this, you must set your equation equal to negative 180 and solve. Negative 180 plus 175 to cancel out the last term, divided by negative 25. Second cosine previous answer, multiply by 4.6 to cancel that out, divide by 2, divide by pi, and add 22.5 to get 23.503. Now you go to your graph and you find where negative 180 is. This would be right here, making the point we found, 23.503, here on our function. This is only half of one wavelength. You need to find a full interval to start your problem. To do so, you must either go to the right or the left to complete the interval. The problem says that it is less than, telling you to go to the left. Greater than means go to the right. To find the other point, you must subtract the answer you just found and do 22.5, which gives you 1.003. You take this number and subtract this from 22.5 because this number is telling you the distance from the point given to the point found. So now you're going this way that much. So you subtract 22.5 minus that answer to get 21.497. This is one full interval. Once you have your interval, you can go back to your problem and start to find where it gets to 0. To do so, you take your both numbers and continually subtract the b value of 4.6 until you reach 0. You can see that the function equals 0 the first time from 0 to 0.503, making that your answer. Then for C, it asks you to find the first time the function is equal to negative 180 after the x value is 50. Now we already found our first interval, so now we can just go up to 50. This time we are adding 4.6 because we're trying to go up to 50, not down to 0. After you add all of your numbers to find the 50, you can see that the number closest to 50, the first one, is 51.103, making that your answer. Now for number 2, you graph a sinusoidal function with a low point of negative 9 at 22.5 and another low point at 25.4. The high point is 23. To find the high point on the x-axis, you must find the difference between these two and add it, divide by 2 and add it to this number. So to start our equation, once again you must find the first term by finding the difference between the high and the low and dividing by 2, giving you 16. This equation is also negative because the cosine starts down and ends down. Then you go on to the 2 pi over PB. This number is the distance between one full wavelength, which is just 25.4 subtracted by 22.5, which gives you 22.9. To find this one, you would divide 2.9 divided by 2 and add it to 22.5. Next, you need your starting value, which is 22.5. So you do x minus that number to represent that. Then you need the midpoint of your high and your low. This is done once again by adding your first term to your high to get positive 7. Now we have our equation, we can move on to the intervals. This one asks you to find the first and second interval where the function is greater than or equal to 10 after the x value of 0. So to do this once again, you must go to your calculator and make it equal to 10. Subtract 7, divide by negative 16, second cosine second answer, times 2.9, divided by 2, divided by second pi, and add 22.5. This gives us 23.312. Now we go to our graph and find that 10 is right here, and so this point must be right here on our function. This time it says that it's greater than or equal to, not less than, so we're going to go to the right to find our other interval. To do so, we must find this point, which is, you take your b value of 2.9 and divide it by 2, and add that to the starting. So 22.5 plus 1.45 equals 23.95. That is the mid of these 2 points. Now we're taking that and subtracting the number we found, which is 23.312, which gives us 0.638. Now we're going to add 0.638 to the 23.95. to get 24.558. This is one interval. Now we can go down and find all the intervals until we get down to 0. Once you subtract them all, we find that the first one is 0.122 to 1.388, and our second interval is 3.012 to 4.228. Now for C, it says find the second time the function is equal to 10 after the value of 50. We must set our equation equal to 50, which gives us 23.312 again. And we have our function, which gives us our one first interval, and now we can continue to add our b value of 2.9 up all the way until we reach 50. And it says find the second time, so the first one is 50.688 and the second is 52.3268. Now number 3. This problem has a high point of 80 when x equals 10.2 and a low point of negative 10 when x equals 10.9. Our first term is 10 plus 80, which is 90, divided by 2 to get 45. This graph is positive because it starts up and it continues on up. Next, to find this term, we find the distance between one wavelength. So this only gives us half, so we must multiply this distance by 2 to get 1.4. Then we need our starting value, which is x minus 10.2. To find our last term, we add 45, or in this case subtract it from our top one to get 35, which means you start at positive 35. With our equation, we can go on to B. B says find the first and second interval where the function is less than or equal to 65 after the x value is 25. To start this once again, we set our equation equal to 65 and find our first interval. This tells us, after you figure this out, you can find that it's 10.387. So go to your graph and find 25 on your line and go across and write 10.387. This one, you must go and finish and find the other interval. So you have to find the distance of this arc to continue on this way and find this number. So you take 10.9 and subtract the number you found of 10.387 to find 0.513 and add that to 10.9 to get 11.413. We now have one full interval on our wavelength. Now we can go on and we can add our b value of 1.4 continually until we reach 25. This one wants the first and second interval of reaching 25. So as we continue down, we find our first one at 25 to 25.413, and our second one at 25.787 to 26.813. Now C asks for the third time the function is equal to 65 after the value of 30. So once we set it equal to 65 again, we have our starting intervals. And it wants the third time after 30. So we're going to add our b value until we reach 30. And the first one is right there. And it wants our second one. And the third one is 32.413. The difference between an interval and a time of the function is an interval has 2 points, one full wavelength, and the time of a function is just one of the two. It's not a set one, it's just one of the points. Now on to number 4. This equation has a low point of negative 50 at 9.5 and a high point of 2 at 11.1. To find our first term, we find the difference of these two and divide by 2 to get 26. This equation is negative because the cosine starts down and continues on to end down. Then to find our b value, we find the total difference of one full wavelength. This gives us half, so we must multiply this distance by 2 to get 3.2. Our starting point is 9.5, so we represent that by x minus 9.5. Then we need the midpoint of our total line, so we would add negative 26 to 2 to get negative 24 as the mid on our line. Now we have our equation, we can go on to b. b says find the first and second interval where the function is greater than or equal to negative 20. We must first set our equation equal to negative 20 and solve. This gives us 10.379. So at negative 20 on our graph, the x value is 10.379. We must continue on to find the interval. To do so, we subtract the given point of 11.1 minus 10.379 to find this distance. We then add that number all the way over to get the second one, which is 11.821. We can go back to our problem now and add our b value of 3.2 continually until we reach 20. Once we do so, we find that the first interval is at 20 to 21.421, and the second is 23.379 to 24.621. C asks us to find the third time the function is equal to negative 20 after the x value of 50. So we have our first interval of our last one of 26.379 to 27.821. So we can add our b value once again of 3.2 continually until we reach 50. The first time we reach 50 is at 50.221, and it wants the third time, so the next one is 51 and then 53. So our answer for C is 53.421. Thank you for watching.